Okay, we have this problem here where a car is initially at rest. It experiences a uniform acceleration where the acceleration is constant. The acceleration ceases after 12 seconds. In other words, the car accelerates from t0 to t12. And at that time, at 12 seconds, the velocity of the car is 31.0 meters per second. So what you have to do is calculate the acceleration of the car during the first 12 seconds and the distance traveled by the car in the first 20.0 seconds. What I would strongly suggest you to do now is for you to pause this video and sketch. Okay, what you should do is sketch a velocity versus time graph for the first 20 seconds. Okay, so the graph that you should obtain, if you were to graph it correctly, velocity in meters per second versus time in seconds, you will see that the graph is divided into two sections. The first section, let me label this section A, which I've drawn with a black line, and then section B, which I've drawn using red ink. Okay, so for the first 12 seconds, the car undergoes uniform acceleration. For the next 8 seconds, it moves with a constant velocity. So when they're asking for the acceleration of the car, what they're looking for is the acceleration in part A, okay, or the acceleration for the first 12 seconds. So for the first 12 seconds, you have a straight line which passes through the origin, and we're asked to find the acceleration. As you should remember, for a graph of velocity versus time, the acceleration is the gradient of the velocity versus time graph. This is from t equals to 0 to t equals to 20 seconds. So how would you calculate the acceleration, or the gradient in this case? So if you recall, acceleration is the gradient of the graph. Well, in this case, I can actually use this formula, v minus u divided by t minus 0. Now, take a note of this. This will be the velocity at time t, while u will be the velocity at t equals to 0. So just have a look at what are the values that we can obtain from the graph. In this case, if you're looking at t equals to 0, your value of u will be 0. And for this particular value of t, I will need to use this time. And at that particular time of 12.0 seconds, the value of v is 31.0 seconds. So all I have to do next is to plug in the values into this equation, which will give me 31.0 minus divided by 12.0 minus, okay, the value of u at t equals to 0 will correspond to 0, and then 0 here. And what you will obtain now is just 31.0 over 12. And if you plug in these values into your calculator, you will get a number that is 2.58 meters per second per second. This value 2.58 is correct to 3 significant figures. So now let us move on to part B of the problem. In this part, we are supposed to find the distance traveled by the car in the first 20 seconds. What we have is just a graph of velocity versus time for the first 20 seconds. So how do you figure out the distance of the graph? You should recall that the displacement is given by the area under the graph for the first 20 seconds, but distance and displacement are two quantities that are quite different. Because for displacement, we need to take into account direction of motion. For distance, we don't have to. So how do we actually calculate the distance? Now, if you look at the motion of the car is just moving in one direction. It's not changing the direction of motion. In this particular case, the distance traveled by the car in the first 20 seconds will be equal to the displacement of the car in the first 20 seconds because it's just moving in one direction. Now, and as you recall, as I mentioned a few seconds earlier, the displacement is equal to the area under graph from t0 to t equals to 20 seconds. Now, I've purposely divided this graph up into two parts, one which is a triangle, which is in blue, and the other which is a rectangle, which is in red. So I'm going to label this part 1 and this as part 2. So I'm going to sum up the areas, or find the areas for individually first, and then sum up the areas to get my displacement. So in this case, my displacement in blue will be half, which is a triangle. So the area under the triangle is half times base times height, half times 12 times 31.0, plus the area of the rectangle, which will be length times width. Let me correct this. I'm supposed to change. Okay. So you have 20.0 minus 12.0 times 31.0. All you have to do is, missed the point here, all you have to do is plug these numbers into your calculator and see what it turns out. And so you will get 434. It's in meters. Now you should make it a habit to leave your answers in 3 significant figures. Okay, and don't forget the units.